Fibonacci series with integral calculus. Fibonacci series with integral calculus. That is the discussion that we are pursuing. Can we do computation in the summation series in Fibonacci series through integral calculus? Personally, I am seeing there are a lot of things that are there. If someone read the book in summation series in Fibonacci series, there are a lot of series that has been generated, hybrid series that has been generated through Fibonacci series only. And proof that has been placed in the book for every series proof is different or something like that. Means for a reader, it becomes very difficult to remember each different proof through the different series. We have brought in successive approximation through integral calculus, and through that all the proof are same. Any summation in the world, any summation series in the world, any can be summed up through a single way of calculation, and that is integral calculus successive approximation. And Fibonacci series is not escaped from it. What is Fibonacci series? I will reiterate, Fibonacci series is nothing but if there is an amoeba tends to divide into two. There is a something called amoeba, and it has a characteristics to divide into two. If amoeba is dividing into two, if amoeba is dividing into two, then what will be amoeba count on a particular day? That is the Fibonacci series. Condition is amoeba every day one amoeba divides into two, only one time. If there is an amoeba, then every day it divides into two. Okay, one time. Every day, one time. So every day an amoeba becomes two, next day two, next day two, next day two, so on. If there is a newborn amoeba, then if it is born on day number one, then day number one, day number two, it will take time to grow up, and day number three onwards, it will start dividing into two on daily basis. This is the new amoeba born. So if I have brought a newly born amoeba today, that is day number one, then day number two, it won't do anything, it will grow up. And day number three, it will multiply into two. Day number four, it will multiply into two. Day number five, it will multiply into two, and so on. Okay, it will never die. Day number three, newborn amoeba will start multiplying into two from day number five after 2 days. Day number four, the amoeba that was born, that will start multiplying from day number six. Day number five, whatever the amoeba is born, it will start multiplying into two from day number seven. How many amoeba are there on day number seven? Then anyone would say the amoeba count on day number six, all amoeba will be alive on day number seven also. Yeah, true. How many amoeba are available on day number seven? Whatever amoeba is available on day number six, all amoeba will be alive on day number seven. True, that is true. Whatever amoeba are available on day number five, all amoeba will have 2 day span. Either it is mother amoeba, child amoeba, whatsoever. They will have two day span to enter into day number seven. That is true. So all amoeba on day number five can double up on day number seven. Okay, then how many amoeba are on day number seven? The amoeba on day number six, they will be alive on day number seven also. Plus amoeba on day number five, which is day number five, they are going to become double on day number seven. So amoeba on day number seven is amoeba on day number six plus amoeba on day number 5, because day number 5 will exactly double on day number 7. So equal amount will come there also. So amoeba on day number x is nothing but amoeba on day number x minus 1, because they will be alive on x the day also. And amoeba on day number x minus 2, because those amoeba, they will divide into 2, they will exactly multiply to its own number on 2 days after. So fx equal to fx minus 1 plus fx minus 2. This is called Fibonacci series. Fx equal to fx minus 1, fx minus 2. Okay, I can say if x starts from 0, Then on 0th day there is no amoeba. On the first day, I am bringing one amoeba, that is child amoeba. So second day, there will be one amoeba only. Third day, there will be two amoeba. Now I can use this formula now. Day number 0, there is no amoeba. Day number 1, there is one amoeba. Okay, day number 0 and day number 1, they cannot go like fx minus 1, fx minus 2. Day number 3, fx will start. So day number 3, fx, where x is 3, equal to fx minus 1, fx minus 2. That is 1 again. So sorry, day number 2. Day number 0, day number 1, day number 2. Day number 2 will be day number 1 plus day number 0. That will be 1 again. Day number 3 will be day number 2 plus day number 1. That will be 2. 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. This is called Fibonacci series. If I write Fibonacci series, then it will be 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. If I talk in the position number, then position number is 0, 1, 2, 3, 4, 5. Tell me what is the amoeba count on position number 5? Then it is 5. Okay, we also call day number as x and number of amoeba as function over x. And this is how it is. We can represent function over x, f, and in bracket x, f close. Function over x, we can rename function over x as u bottom right x. U bottom right x. This is also called subscript. Means we can nominate a count of amoeba on a particular day. We can symbolize the number of amoeba on particular day x, particular day number x as fx function over x, or u bottom right x, ux, not function over u and in bracket x bracket 4, not like that, u bottom right x, ux, or f bracket open x bracket close, fx. Okay. Now in that way, I can say my Fibonacci series is u1, u2, u3, u4, u5. These are the days 1, 2, 3, 4, 5, 6. U will be the value. U1 is 1, U2 is 1, U3 is 2, U4 is 3, U5 is 5, U6 is 8, and so on. Okay, now there is one intricacy. The master of the series in Fibonacci that I am seeing is it's called PMN. This is what I am saying in the book. P, right? P, and in the subscript bottom right, subscript right, M comma N. PMN. PM comma N. What is PM comma N? PM comma N is UN into UN plus 1. Make sense? P P P M comma N equal to UN into UN plus M. Okay, what I'm trying to say is if I write P 5 comma 1 means it will be same as U1 multiplied by U6. Yeah, U1 multiplied by U6. What is P1 comma 1? U1 into U2. U1 into U2. Okay. Multiplication of two Fibonacci number guided through PMN, M comma N, where N is the Fibonacci day number, N is the Fibonacci day number, and M is next. It is multiplication of two Fibonacci number. First is UN, N is the day number, and second is UN plus M after M days. Makes sense? So we have already done P11 knowingly, unknowingly. Sorry, P 1 N. P1 comma N means P11, P1, sorry, P11, P12, P13, P14. P11 is U1 into U2. P12 is U2 into U3, like so. u1, u2, u2, u3, u3, u4, u4, u5, and so on. Then we did P, P2, comma N means P1, P3, P2, P3, P3, P5, P3, P5, next up, P1, P3, P2, P4, 2 gap will be there because M is 2, P3, P5, and so on. Okay, what about we will do till 3, M equal to 3. Then we'll try to calculate a generic formula of Pm, comma N, where M is fixed and N is variable. Means Pm, comma 1 plus Pm, comma 2 plus Pm, comma 3 plus Pm, comma 4. That will come as P1 into, sorry, U1 into U1 plus M. This is one number. Another number is P2 into P2 plus M. Next is P3 in, sorry. There are two things. One is P and one is U. P is a new way of representing the new Fibonacci series, hybrid Fibonacci series. So in a hybrid Fibonacci series, P, P, M, comma N. If this is P, bottom right at subscript M, comma N, that is equal to U N into U M plus N. If I say I want summation of all the P where N is variable, M is constant. M for monkey, M is constant, and N for national. N is variable. In that manner, it will come as PM1 plus PM2 plus PM3 and so on. That will come as U1 into UM plus 1. Another will be U2 plus into UM plus 2. Next will be U3 into UM plus 3 and so on. And all we have to add in summation. There can be a scenario where M is variable and N is constant. Monkey is variable and N is constant. Then summation M equal to 1 to N P Mn. That will be P1N, where N anything I have taken. P1N plus P1M plus P2N, P3N, P4, and so on. That will come as UN into UN plus 1, UN into UN plus 2, UN into UN plus 3, and so on. If I say N is variable, national is variable, and monkey is constant, then summation N equal to 1 to N equal to 1 to N to N, any N, and then P M, comma N. That will be same as PM1 plus PM2 plus PM3 and so on. That will be U1 into U1 plus M, U2 into U2 plus M, U3 into U3 plus M, and so on. Okay, so both things. Right now we are seeing N as variable and M is constant. So we will try for M equal to 3, means every term will be U1 into U4. M equal to 2. M equal to 2. U1 into U3. Hope. So I believe we tried first M as 0. Then U1 into U1. U1 into hope. First we tried U1 U2. Then we tried U2 U3. I think that is done. U1 U3 is done. We will try U1 U4. Hope. Very big. We will try U1 U4. I think so. No? Okay. We have tried U1 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 U2 U2 U3 U3. Yes. This is what we have tried. Okay, I'll reconfirm if Mn is correct or not. If M is variable, then it is UM. If M is variable, means sorry, if N is variable and M is whatsoever, PMN is n, that is for sure. U into m plus n minus 1 or m plus n. I think that I have to make sure. Whatever. Okay, we will see n as variable where we will use term m only. Right now, m we are using a numerical value. Now we will try now u1 into u3. u1 into u3 plus u2 into u5 plus u3 into u6. U1 into u1 into u3 u1 into I think we have done it. U1 into u3. Okay, u1 2 gap. I'm really confused. What I did not do, did what I did not do. Anyway, u1 into u3. If I take, then how much it will come? U1 is ux into ux plus 2. Ux into ux plus 2. We have done. Where m is 2, we have done it. Ux plus 2, we have done it. We will try now m equal to 3. M equal to 3 when it is, then it will be u1 plus u1 plus 3. Yeah, I think we are right. We are on right track. We will try m equal to 3. Then we will try for generic m. Then we will try m as variable, n as constant. 1 or 2 we will take, and then we will take generic generic n, where n is variable. Right now m is variable, and we are taking for particular m. Now we will take m equal to 3. Then we will compute for m. This is the most intricate Fibonacci summation. If we are able to achieve through integral calculus, it is something like our integral calculus is a generic way to calculate the summation in series. There is no fault in that. And this is a new thing, and this will create a revolution. Means people who are trying to understand calculus, for them it will be a big thing. Second thing is people who are trying to innovate the kind of continuous function through a discrete function. How to convert a discrete function into continuous function? This can be one of the way, that is called successive approximation. And that way, someone can transform a discrete function to continuous function. Once continuous function is received, then someone can go with the kind of sub area calculation. If someone has sub area, then he can go with integral calculus. Integral calculus is nothing but calculation of area only. What else is integral calculus? Integral calculus is nothing else than this. Integral calculus is only about summation of area. Yeah, it is only about summation, rather calculation of area. Okay, but integral calculus is like multiplication. You can use it. It is a superset of multiplication. Integral calculus can be addition also. You can take it, no problem. But integral calculus, if I have x-axis and if I have a graph over x-axis, this is function over x. This is x-axis, this is function over x. If I have a graph like this, then fx dx will calculate area underneath it from x1 to x2. That is the limit we place, x1 to x2. Fx dx is area underneath from x1 to x2. Okay, this is typically the usage of integral calculus. So we will use now what we want. We want m equal to 3, u1, u4, u1, u4 plus u2, u5 plus u3, u6 plus u4, u7 and so on. un plus 3. This is what summation I want. Let's take n as odd number. What are you saying? I am saying u1, u3 plus u2, u5 plus u3, u6 plus u3, u1, I'll try to do it again. u1, u4 plus, if I said something else, u1, u4 plus u2, u2, u5 plus u3, u7. Okay. un plus 3. This is what I want. un plus 3. u1, u4. Yeah. u2, u5 n plus 3. u3, u6. Yeah. Plus 3. u4, u7 and so on. un plus 3, where n is odd number. N can be even number also, because result will be different for odd and even. N is odd number. Okay, so now I can write I want u1 u4 plus u2 u5 plus u3 u6 and so on, where ux plus 3, last will be un plus 3. Okay, ux equal to ux minus 1 plus ux minus 2. This is Fibonacci series. Number in Fibonacci series on day number x, amoeba count ux is ux minus 1 plus ux minus 2. If we talk in algebra, then it is phi 1 to the power x minus phi 2 to the power x by a square root of phi, that is ux or fx, where phi 1 is 1 plus a square root of phi by 2, phi 2 is 1 minus a square root of phi by 2. Okay, 1 minus a square root of pi by 2 is certainly negative, certainly. Okay, in that manner, I can say ux equal to, now let rename it. Let bring another term called a and b, where a equal to pi 1, 1 plus a square root of pi by 2, that is always positive. B equal to minus pi 2, that will be a square root of 5 minus 1 by 2, that will always be positive. Now I can rephrase it as for the even x. The fx is a to the power x minus b to the power x by square root of 5. For odd x, fx equal to a to the power x plus b to the power x by square root of 5. Plus minus will come if b is positive. If b is negative, that is pi 2, then I can say minus pi 2 to the power x. But if I take b as minus pi 2, then minus 1 to the power x will start flipping its sign based upon even and odd. Okay, in that manner, now we will use our concept our concept of successive approximation to calculate the summation and series u1 u4 plus u2 u5 plus u3 u6 plus u4 u7 plus un plus 3, where n is odd number. Okay, in that manner, now in this series we have, if I say, okay, tell me what is your number at position x, then it is ux plus 3. Okay, where x can be odd or x can be even. I mean, I can segregate this into two parts again. Anyway, n I have taken odd, and whatever the series we are saying, we will segregate into two parts. The first part is u1 odd part, odd number. u1 u4, u3 u6, u5 u8, u7 u10, and so on. Second part is for even number u2 u5, u4 u7, u6 u9, and so on. Okay, at the end, when I have taken n as odd number, then even number will be one less than that. So last term will be un minus 1, un minus 1 plus 3, un minus 1, n plus 2. And this is the second last term, that is even. N, considering n is odd, then second last term will be un minus 1 un plus 2. And last term will be un plus 3, where n is odd number. So last even number will be one less than the odd number. Anyway, now concept is that how we progress. What we want? We want summation sigma sign. Sigma x equal to 1 to x equal to n fx. This is what actually I want. Now I segregated into two parts. First part is summation x equal to 1 to n fx, where x will jump 1, x equal to 1, x equal to 3, x equal to 5, x equal to n. This is for odd number. For even number, summation x equal to 1, x equal to 2, 2 to x equal to n minus 1 fx, where fx will jump 1, 2, 4, 6, 8. So now two series I have to calculate, and then we have to add, and we will get the final summation. For odd, fx is ux plus 3. For even, fx is ux plus 3. Same thing. But here it will start from 1 to n. Here it will start from 2 to n minus 1. Anyway, now in the successive approximation, many times we have demonstrated it. I don't mind demonstrating it once again. So in successive approximation, if I take x, okay, if I take this as x-axis, then these are the x value: x equal to 0, x equal to 1, x equal to 2, x equal to 3, x equal to 4, x equal to 5. At x equal to 1, we have u1 into u4, u2 into u5, u3 into u6, u4 into u7, and so on. Okay, if that is the situation, what is summation at the odd number? That will go up till un plus 3. What is summation of even number? That will go from 2 to un minus 1, un plus 2. Okay, this is, if I take only for odd number, then I have fx at x is odd, fx at ux plus 2, x plus 3. If I take only for even number, then I have fx equal to ux into ux plus 3. Same thing. In function, there is no problem. Limit is the problem. Limit is x 1, if I 1 to n, and here limit is 2 to n minus 1, where n is odd number. That is the problem. One thing. Second thing, if I take the fx, let's take only odd number. If I take only odd number, then there will be a height, that is fx. If this is x-axis, this is function over x-axis or y-axis. So function over x-axis at x equal to 1, x equal to 3, x equal to 5, and so on. If I connect all the top point, I'll get fx. That is ux plus 3. If I connect at even number, all the top point, I'll get fx as ux into ux plus 3 again. Same. Anyway, now I have to add all the odd verticals, and then I have to add all the even verticals. Then finally I have to add together. For the all vertical, I have fx, and this is a discrete function. It is defined only at x equal to 1, 3, and so on. Okay, can I have a continuous function gx? Gx is a continuous function, and it is, I have to find what is gx. But what is the associativity? What is the relationship between fx and gx is, if I have x equal to 1 and x equal to 3, if I take area strip like this and it hits the gx, then this area is limit x equal to 1 to x equal to 3 gx dx. X equal to 3 and x equal to 5, this will go and hit x equal to 3 to x equal to 5 gx dx, that is the area. Can this area will be exactly same as left hand side fx? Means fx at x equal to 1, that is u1 into u4, equal to limit x equal to 1 to x equal to 4, x equal to 4 gx dx. Hop, I made a mistake. Okay, I'll try again. So I'm saying x, I have sample at x equal to 1, x equal to 3. At these two positions, I calculate the area. This is gx. Then it is limit x equal to 1 to 3 gx dx. Makes sense? That will be similar to left hand side fx. Fx at x equal to 1. That is u1, u4. Yeah. So u1, u4 equal to limit x equal to 1 to 4 gx. Sorry, x equal to 1 to 3 gx dx. Next is x equal to 3 to 5 gx dx. Last will be x equal to n plus 2 gx dx. That will be same as fx at x equal to n, un plus 3. Makes sense? Now, if for any x, what is ux? Ux into ux plus 3. That will be same as right hand side area with gx. Limit x equal to x plus 2 gx dx. If I find gx in this manner, then I know the gx. If I know the gx, and then if I calculate all the area of all the, if I calculate the summation of all the sub area from 1 to 3, 3 to 5, n to n plus 2, that will be the same as left hand side addition of all the fx. This is what we want. Summation x equal to 1 to n fx equal to sum equal to limit 1 to 3 gx dx plus 3 to 5 gx dx plus n to n plus 2 gx dx. Okay, someone can write in summation also. Okay, let's try to do for x. Fx at x equal to x equal to limit x to x plus 2 gx dx. If I find gx, I will do final summation from x equal to 1 to n plus 2 to have the full area. That will be summation of all the series because one sub area corresponds to 1 in fx. We get it? The solution. Okay. So we will proceed in this manner. So fx at x equal to ux plus 3 ux, where x is odd number, it will be a to the power x plus b to the power x by a square root of 5 into a to the power x plus 3 minus b to the power x plus 3 by a square root of 5. If x is odd, x plus 3 will be even. For even, it will be minus. A square root of 5, a square root of 5 will be 5. That we will leave right now. We don't need. So only numerator we will see a to the power x plus b to the power x into a to the power x plus 3 minus b to the power x plus 3. It will come as a to the power 2x plus 3 minus b to the power 2x plus 3 plus a to the power x b to the power x in bracket a to the power 3 minus b to the power 3. Makes sense? A to the power x b to the power x in bracket a to the power 3 minus b to the power 3 will come as a to the power x plus 3 a to the power x plus 3 b to the power x minus a to the power a to the power x b to the power x plus 3. This is what we have. Okay. A into b is 1. If a is 1 plus a square root of 5 by 2 and b is a square root of 5 minus 1 by 2, a into b is 1. So a to the power x, b to the power x will convert into 1 only. Now we have to calculate a to the power 3 minus b to the power 3. A minus b, a square plus ab plus b square. A square plus b square is 3 plus ab 4. A minus b is 1, 4. So we are getting fx when x is odd number a to the power 2x plus 3 minus b to the power 2x plus 3 plus 4. If x is even number, it will come as minus 4. That's it. There is no other difference. Minus 4. Ux plus 3 when x is even, it will be a to the power x minus b to the power x minus. And there it will be a to the power x plus 3 plus b to the power x plus 3. Then it will come as minus 4. Anyway. Now we have fx as a to the power x plus a to the power x plus a to the power 2x plus 3 minus b to the power 2x plus 3 plus 4 equal to limit x to x plus 2 gx dx. I have to find gx dx in that manner. We will start gx with something. Fx equal to gx dx. Dx equal to dfxy by dx. If I do so, then dx will be 2 log a to the power 2x plus 3 minus 2 log b to the power 2x plus 3. Okay, then nothing. If I place here, then integration will come as a 2 log a to the power 2x plus 3 by 2 log a minus 2 log b to the power 2x plus 3 by 2 log b. They cancel each other and it will become a to the power 2x minus b to the power 2x. Limit is x to x plus 2. A to the power 8, how much it will be? 2x plus 2, 4. A to the power 2x plus 7. A to the power 2x plus 7 minus a to the power 2x plus 3. Makes sense? Minus b to the power 2x plus 7 plus b to the power 2x plus 2x plus 3. Okay, if I take a to the power 2x plus 3 as common factor, a to the power 4 minus 1 minus b to the power 4 in bracket b to the power 2x plus 3 minus 1, 2x plus 3, b to the power 2x plus 3 minus 1. I'll try again. Okay, I'll take a to the power 2x plus 3 as common, a to the power 2x plus 3 in bracket a to the power 4 minus 1 minus b to the power 2x plus 3 in bracket b to the power 4 minus 1. Means a to the power 4 minus 1, b to the power 4 minus 1 is extra. Anyway, left hand side plus 4 is also there. If I settle down everything, I'll get gx as a to the power 2x plus 3, 2 log a into a to the power 2x plus 3 by a to the power 4 come down minus 1. Minus 2 log b to the power 2x plus 3 by b to the power 4 come down minus 1 plus 2. 2. 2 integration is 2x, x to x plus 2 will be x plus 2 minus x, 2. 2 into 2, 4. Makes sense? Okay, in that manner we are getting it. So gx is 2 log a by a to the power 4 minus 1, not 4 minus 1, come down minus 1. 4 into a to the power 2x plus 3 minus 2 log b by b to the power 4 minus 1 whole multiplied by b to the power 2x plus 3 plus 2. Okay, if I talk in even number, then it will be minus 2. Here it is plus 2, there it will be minus 2. Anyway, to calculate the whole summation series for odd and even, for odd it is summation x equal to 1 to n fx. For even it is summation x equal to 2 to n minus 1 fx. So left hand side summation will come as gx dx from 1 to n plus 2. Next will be gx dx from 2 to n minus 1. Sorry, 2 to last. If n is even, then n minus 1 plus n minus 1 plus 1, n plus 2. 1 is 1 to n plus 2 because last sum area is n to n plus 2 if n is odd. For even n minus 1 to n minus 1 plus 2, n to n minus 1 to n plus 2. So we will get it now, limit x equal to 1 to n plus 2 dx dx. This is for x as odd number, x as even. It is limit x equal to 2 to n plus 1 dx dx. Okay, here gx, if I settle down gx dx, 2 log a will go away immediately. A to the power 2x plus 3 by a to the power 4 minus 1. Limit is 1 to n plus 2. Let's settle down the odd first, then we will settle down the even. Limit is 1 to n plus 2. 1 to n plus 2 where n is odd. There also n is odd. 1 to n plus 2. A to the power 2x plus 3. A to the power 2x plus 7 minus a to the power, how much? A to the power 2x 1 plus 5. A to the power 2x plus 7 minus a to the power 5 by a to the power 4 minus 1. A to the power 4 minus 1 I can rewrite as a square minus 1, a square plus 1. A square minus 1 where a is the square root of 5 plus 1 by 2, it will come as a 1 again. A into a 1 plus a square. Numerator I can take a out. A to the power 2x plus 6 minus a to the power 4. I think so. Minus a to the power 4 by 1 plus a square. A to the power 2x plus 6 minus a to the power 4 by 1 plus a square minus, now we have b to the power 4 minus 1. B square minus 1, b square plus 1. B square minus 1 will become minus b. B is the square root of 5 minus 1 by 2. So minus b minus, it will become plus, and I'll take out b from there. It will become b to the power 2x plus 6 minus b to the power 4. Makes sense? Plus 2. 2x 1 to n plus 2. N plus 1 by 2. N plus 1 by 2. So we are getting this as a to the power 6 minus a to the power 4 by 1 plus a square minus b to the power 2x plus 6, 2x plus 6 minus b to the power 4 by 1 plus b square plus n plus 1 by 2. If I take for the even number limit will be 2 to n plus 1. 2 to n plus 1 will be how much? 2x plus 3. 5, a to the power 5. A to the power 2x plus 5 minus a to the power 7. Similarly, I'll take out a to the power 4 minus a to the power 6. A to the power 2x plus 4 minus a to the power 6. Makes sense? Okay, last is minus 2. 1 to n, 2 to n plus 1, n plus 1 minus 2, n minus 1, minus n minus 1 by 2. This side we have plus n minus 1 by 2, minus n minus 1 by 2. Oh, sorry, 2, I'm sorry, 2 into n plus 1, not n plus 1 by 2. 2 into n plus 1. And here minus 2 into in bracket n minus 1. If I settle it down, it will become 2 plus 2, that is 4. Okay, Let's settle down here. A and A to the power 2x plus 6, A to the power 2x plus 4. I think so. So we will take out A to the power 2x plus 4 as common. Then it will become 1 plus A square. And we have minus A to the power 4 minus A to the power 6 minus A square 1 plus A square again. 1 plus A square in denominator, it is waiting now. So it will become A to the power 2x plus 4 minus A to the power 4 plus b to the power b minus b, it will become plus b to the power 2x plus 4, 2x plus 4 minus b to the power 4. Makes sense? A to the power 2x plus 4 plus b to the power 2x plus 4. Okay. Minus a to the power 4 minus b to the power 4 plus 4 plus 4. Okay, how much is minus a to the power 4 minus b to the power 4? If I try, minus will go outside. A to the power 4 plus b to the power 4. How much it will come? A square will be 1 plus a square root of 5 by 2. A square will be 6 plus 2 a square root of 5 by 4. Again a square. It will come 36 and 5 into 4, 20, 56. 56 plus something a square root of 5 by 16 plus b to the power 4, that will come 56 again, minus something a square root of 5 by 16. This plus and minus, they will cancel each other. 56 plus 56 by 16, 56 into 2 by 16, that will come as 8 into 2, 16, and 8 7 yeah, 8 7 7 into 2 by 2, 7 plus minus 7. So answer is a to the power 2x plus 4 minus b to the power 2x plus 4 minus 7 plus 4 minus 3. Okay, anything can I bring with this? A to the power 2x plus 4 minus b to the power 2x plus 4 minus 3. Anything can come out. Can I think about a number? A to the power x, sorry, a to the power n, a to the power n plus b to the power n, a to the power n plus b to the power n multiplied by a to the power multiplied by multiplied by a to the power n plus 4. I think so. A to the power n plus 4 minus plus, I think plus b to the power n plus 4. How much it will be? A to the power n plus 4, a to the power n plus b to the power a to the power n. So much confusion. I try again. A to the power n plus 1, a to the power n plus 1 minus b to the power n plus 1. Okay, if n is odd number, n plus 1 will be even number. A to the power n plus 1 minus b to the power n plus 1. I think so. Multiplied by a to the power n plus 3 plus b to the power n plus 3. Something highly confusing. Anyway, what we have got now? Okay, what we have got now is a to the power 2n plus 4 I think plus minus. Okay, I'll remember. Try to remember again. For odd series we had, I believe it was minus. So minus and b square minus 1 was minus, so minus minus plus. So a to the power 2n plus 4 plus b to the power 2n plus 4. This is what I remember. A to the power 2n plus 4 plus b to the power 2n plus 4. Okay, and then we have minus 3. It is coming as minus 3. This is what I remember. Okay, I believe I'll proceed on this. What is the solution? I believe it will come as un plus 1, un plus 3. This is what thing. Last time it came as un plus 1, un plus 2. I believe this time it will come as un plus 1, un plus. How much it is? Un plus 1, un plus 3. Un plus 1, un plus 3. N is odd number. N plus 1 will be even number. If n plus 1 is even number, n plus 2 will be odd number. N plus 3 will be even number again. Makes sense? N plus 1, n plus 3. So a to the power n plus 1 into a to the power n plus 3, how much? It will be 2n plus 4 only. Okay, but it should come as positive, I think so. Okay, we'll try again. Okay, let's try again. What is un plus 1 into un plus 3? Un plus 1, when n is odd number, then n plus 1 is even number. N plus 3 is also even number. A to the power n minus 1 minus b to the power n minus 1. n plus 1. A to the power n plus 1 minus b to the power n plus 1. A to the power n plus 3 minus b to the power n plus 3. Minus will be there because n is odd number, then n plus 1 and n plus 3 are even number. If I multiply it, it will become a to the power 2n plus 4 plus b to the power 2n plus 4. Makes sense? And then minus a to the power n plus 1, b to the power n plus 1. And then in bracket it will be how much? Okay, it will be, I believe it will be a to the power 3 plus b to the power 3, a to the power n plus 1, b to the power n plus 3. If I do that, if I take n plus 3 and another is b to the power n plus 1, a to the power n plus 3. If I take a to the power n plus 1, b to the power n plus 1, it will come as b square a square, b square a square. That's it. Okay, we'll try now. So minus a to the power n plus 1, b to the power n plus 1. It will come as a square plus b square. How much is a square plus b square? It will come as 6 plus 6 by 4, 3 minus 3. It will come as minus 3. So if I have something a to the power 2n plus 4 plus b to the power 2n plus 4 minus 3, then it is un plus 1 un plus 3. What we have got here? A to the power 2n plus 4 plus b to the power 2n plus 4. This is what I remember. Minus 3 only, same thing, minus 7 plus 4, minus, exactly. So the summation of the hybrid Fibonacci series u1 u4 plus u2 u6 plus u3 n plus n plus 3 un plus 3 u1 u4 plus u2 u5 plus u3 u6 plus u4 u7 un plus 3 is coming as un plus 1 un plus 3. This means that if now gap is 3, if gap is 1, what we received previous one, that was un plus 1 whole square. First we got un plus 1 whole square, then we got un plus 1 un plus 2. Now we are getting un plus 1 un plus 3. Now m is 3, earlier m was 2, m was 1. Now we will try for generic m. Will it come as un plus 1 un plus m? If I try for generic m, pmn will come as pmn, that is un into un plus m. If I calculate that, make it as a series where n is variable, n for nation, that is variable, will it come as un plus 1 into un plus m, un plus 1 into un plus m. Anyway, even number is pending. We calculated for n as odd number. Even number is pending. So that will calculate, then we will generate for the generic m. Mind blowing, amazing. This we have started summation series, integral calculus, same procedure we are following for any number of series, infinite series. Okay, please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number. It is not available in any of the book. Anyone can try.